Dear students, I am Dr. T. Manjula, Associate Professor, Hindustan College of Engineering and Technology. I am going to discuss few points about Boolean laws and its implementations. Content in this presentation: introduction about Boolean functions, axioms and laws of Boolean algebra, implementation of Boolean function, minterms, maxterms, canonical forms and standard forms. First, we will see the introduction to Boolean function. Boolean algebra is an algebra that deals with binary variables and the logical operations. A Boolean function described by an algebraic expression consists of binary variables, that is, the constant zeros and ones, and the logical operation symbols. It is developed by George Boole in the year of 1854. And then in the year of 1938, the Claude Shannon introduced a two-valued Boolean algebra called as switching algebra. It represents the properties of bistable electrical switching systems. Boolean algebra, like any other deductive mathematical system, may be defined with a set of elements, set of operators, and a set of unproved axioms and postulates. A set with innumerable number of elements is specified by braces, that the elements in the set A are number 1, 2, 3 and 4. Axioms and laws of Boolean algebra. Axioms or the postulates of Boolean algebra are a set of logical expressions that we accept without proof and upon which we can build a set of useful theorems. For example, for AND operation, axiom 1 is 0 into 0 equal to 0. Axiom 2 is 0 into 1 equal to 0. And the axiom 3 is 1 into 0 equal to 0. Axiom 4, 1 into 1 equal to 1. See, likewise, OR operation and the NOT operations have been done in the axiom laws and Boolean algebra. Some other AND laws: law number 1 called as none law, A into 0 equal to 0. And then law 2, A into 1 equal to A, that is called as identity law. Law number 3, A into A equal to A. It is also called as impotence law. See, like this, R laws are classified into law 1, law 2 and 3. Law 1, A plus 0 equal to A, where A plus 1 equal to 1 and A plus A equal to A, it is also called as impotence law. Important laws of Boolean algebra: associative law, commutative law, identity element. Where associative law is defined as a binary operator star on a set of S's said to be associative whenever x into y into z is equal to x into y z for all the values of x, y, z Boolean functions. A plus b plus c is equal to a plus b plus c. Law 2, a into bc equal to ab into c. Commutative law, it is defined as a binary operator star on a set S is said to be commutative whenever x into y equal to y into x for all the values of x, y, z belongs to set S. Commutative law, a plus b equal to b plus a, where ab equal to ba. And identity elements, a set S is said to be have an identity element with respect to a binary operation star on S if there exists an element E belongs to S, and so E into X equal to X into E. Some of the identity elements: examples, A into B plus C equal to AB plus AC. Law number 2, A plus BC equal to A plus B into A plus C. Next, we will see De Morgan's theorem and absorption law. De Morgan's theorem. This theorem explained that the complements of the product of all terms are equal to the sum of the complements of each and every term. That is, a plus b dash, it is equal to a dash into b dash. ab dash is equal to a dash plus b dash. And absorption law. This law enables a reduction in a complicated expression to a simpler one by absorbing like terms. That is, a plus ab equal to a. And law number 2 is a into a plus b is equal to a. Next, we will see the Boolean function. A Boolean function is described by an algebraic expression consists of binary variables, the constant 0 and 1, and the logic operation symbols. Here the f variables, that is the set of binary values, are expressed in terms of either variable operators and the constants and grouping or parenthesis variables. Consider an example for the Boolean function f1, which is equal to x plus y dash z. It is a Boolean function, expresses the logical relationship between the binary variables, and it is evaluated by determining the binary value of the expression for all the possible values of the variable. Here the function f1 is equal to 1 if the x is equal to 1, or if both y dash and z are equal to 1. f1 is equal to 0, otherwise the complement operation dictates that when y dash equal to 1 or y equal to 0. Therefore, f1 equal to 1 if x equal to 1 or if y equal to 0 and z equal to 1. It is clearly explained by the truth table for f1. Let a function f dash depends on n variables. There are 2 power n rows since there are 2 power n possible binary pattern or combinations for n variables. It enumerates all the possible contributions of variable values and the corresponding function values. A unique representation of a Boolean function is truth table. If the two functions are identical, then the truth tables of the functions are equivalent. Truth table can be used to prove the equality theorems. Next diagram is a gate implementation of f1. It is implemented with the basic gates, that is AND gate, NOT gate and OR gates. Now the y is given as input to the NOT gate, then the output is y dash, and the x is given another output to the AND gate, then the output will be y dash into z, and it is given as input to the OR gate, then the another input of OR gate is x, output will be f1, which is equal to x plus y dash into z. Here is the important definitions of Boolean algebra. First one, literal. A variable or its complement. Product term. Literals connected by star. Sum terms. Literals connected by plus value. Min term. A product term in which all the variables appear exactly once, either complemented or uncomplemented. Assume three variables a, b, c and j equal to 3, bj equal to 0, 1, 1, and its corresponding min term is denoted by a dash b, c instead of 0, 1, 1. Max term. A sum term in which all the variables appear exactly once, either complemented or uncomplemented. For assume three variables a, b, c, where j equal to 3, then bj equal to 0, 1, 1. And its corresponding maximum term is denoted by mj equal to a plus b dash plus c dash. Canonical form. Boolean functions are expressed as a sum of minterms or the product of max terms are said to be in the canonical form. This is the truth table for minterms and the max terms. See like that, three variables, say for example 0, 0, 0. The equivalent min term is denoted by m0, which is equal to x dash, y dash and z dash. And the equivalent max term m0 is equal to x plus y plus z. And 0, 0, 1, x dash, y dash, z for min term, and max term is x plus y plus z dash and likewise. Canonical forms. Every function f has two canonical forms, that are canonical sum of products and canonical product of sums. In the canonical minterms included are those mj such that f equal to 1. Canonical product of sums max terms included are these mj such that f equal to 0. The canonical sum of product form of f1 of a, b, c, which is equal to m1 plus m2 plus m4 plus m6, which is denoted by a dash b dash c plus a dash b c dash plus a b dash c dash plus a b c dash. And the canonical product of sum form f1 is f1 of a, b, c is equal to m0 into m3 into m5 into m7. which is denoted by a plus b plus c, a plus b dash plus c dash, a dash plus b plus c dash, and a dash plus b dash plus c dash. Standard forms. Another way to express the Boolean function is a standard form. In this configuration, the terms that forms the function may be contains 1, 2 or 3 arrays and the number of literals. It also have two types, that are sum of products and product of sums. Sum of products. Boolean expressions contains terms called product terms with one or more literals and each other. Product of sums. Boolean expressions containing terms called sum terms, and each term may have any number of literals. For example, f1 is equal to y dash plus xy plus x dash y z dash, and the product of sum f2, which is equal to x into y dash plus z, x dash plus y plus z dash. Thank you for watching this video.